Welcome to our MAT-143 video series. In this video, we'll explain the difference between empirical and theoretical probability. Empirical probability has us perform an experiment, look at the results, and use those results to calculate probability. In this problem with empirical probability, a student will roll two six-sided dice 20 times, add the two dice together, and get the results that you see here in column A. Based on those results, we'll find the answers to A, B, and C. Before we begin, we'll select all of our data and sort it to make it easier to read. We'll start by clicking on cell A6, hold the mouse button down, and drag it down until we have all of our results selected. When you move your mouse toward the bottom of the screen, the list will scroll down. Continue to do that until you reach the end of your list. Then, and only then, release the mouse button and go to the upper right in the editing section where we see sort and filter. We're going to sort smallest to largest. That's the first option. Click on this, and now our results are sorted from the lowest going up to the highest. Now we'll calculate part A, the probability of rolling a sum of 8 or higher. We'll scroll down on our list and look for results that are 8 or higher. Using our mouse wheel, we will move downward and locate where the 8 result starts. We're looking for anything that is 8 or higher. Now we'll select all of the numbers starting from 8 and going upward. On the list, that will be the numbers below the 8. We'll click on the 8, which is in cell A20. Move our mouse down to select the rest of the list, which is the numbers higher than 8, and release the button on our last result. After you do this, look in the lower right-hand corner of your screen where it says Count. I'm highlighting it with my mouse right now. And we can see there are 6 results that are 8 or higher. Therefore, we'll say the probability is 6 out of 20. To express this as a decimal, we can say equals 6/20. The slash will perform division. When we press enter, we have a probability of 0.3. We may also represent this as a fraction in Excel. If we want to represent a fraction, we press the apostrophe key and then 6/20. 0.3 is the representation as a decimal number. 6/20 is the representation as a fraction. We'll repeat this process for part B. We're looking now for the probability of rolling a sum less than 6. So let's look at our list again, and we want only the numbers less than 6. So for the low numbers, we're going to start at the top of our list at the 2. Click, hold the mouse button down, and select everything until we reach 6. Now, 6 will not be included in this list, so we will not include these 3 6s. We're going to only include the things less because the wording of the question says only less than 6, but not equal to 6. In the lower right-hand corner of the screen, we can see the words count 10, which I'm highlighting now, and that's out of 20 because that's how many times we rolled the dice. So we'll write that that's 10 out of 20. To represent this as a decimal, we'll say equals 10/20. And then to represent as a fraction, we'll say apostrophe 10/20. Notice that as we entered this calculation, it cut off part of column J, and we can widen column J by moving our mouse in between column J and column K. Looking at the double arrow, we click, move it to the right, and make more room for our text. Now we can look up the probability of rolling exactly 7 for part C. If we look at our list, 7 has only a single result. We have only one 7 in the list. Therefore, we'll say that our probability is 1 out of 20. We can enter that as a decimal by saying equals 0/1/20, and as a fraction by saying apostrophe 1/20. Now, these results are based entirely upon the data that's in column A. However, the theoretical probabilities could be completely different. We'll have a look at that now. When you're calculating theoretical probability, we are not actually running an experiment. What we'll need to do for theoretical probability is look at all of the possible outcomes for this test. In the blue column, I've listed the results for the first die, and in the orange column, I've listed the results for the second die. What we'll have to do for theoretical probability is to create a probability space and just see what all of the possible outcomes of these dice rolls could be. Imagine if I rolled a 1 on the first die, which I'm selecting in the green box, and a 1 on the second die, which I'm selecting in another box. We know that 1 plus 1 equals 2, and so we'll enter the number 2 at this intersection. Now, if I had rolled a 1 on the first die and a 2 on the second die, you can see where I've selected those boxes. We know 1 plus 2 would make 3. If I rolled a 1 on the first die and a 3 on the second die, I know 1 plus 3 makes 4. We can follow this pattern to fill in the entire first row. We can assume the next box will be 5, and the one after that 6, and the one after that 7. We can similarly fill in all of the rows in this fashion. If we roll a 2 on the first die, and a 1 on the second die, 2 plus 1 makes 3. Continue across, 2 plus 2 would make 4, and we'll continue following the same pattern. Following the same process, we can expect 3 plus 1 to be 4, and we can expect, just as before, every time we go to the right by one cell, we'll go up by 1. We can also expect that 4 plus 1 would make 5, and we'll follow the same pattern. 5 plus 1 would make 6, and again, we'll go across. And finally, 7, and complete this row. Now we've created the probability space. We can see that on this table, all of our numbers are between 2 and 12, just as we would expect for adding two dice together. But some numbers come up more often than others. We may see that 2 appears only once, while 6, for example, appears more times. Using this information, we will calculate theoretical probability. We'll start with problem A, finding the probability of a sum of 8 or higher. We'll start by selecting all the results that say 8. We'll click on the first 8 that we see, hold down the control button, and click on all of the other 8 results. Since we are also going for 8 or higher, we will click all results higher than 8 as well. You can see that we've selected about half of this table. In the lower right corner, we see that we have a count of 15. Now that's going to be 15 out of how many total results we've made in the table. So we'll select the entire table now to count the total number of results, and we can see that count is 36 down here in the lower right. So we'll say that our probability of rolling a sum of 8 or higher is 15 out of 36. To get the decimal form, we'll say equals 15/36. And Excel returns the decimal 0.416 repeating. To write it in fraction form, we'll say apostrophe 15/36. Using the same technique, we'll look at the sums less than 6. So this time we will not be selecting the 6 because we want only the numbers strictly less than 6. So make sure you leave 6 out for part B. So do not select 6, but go down one number to 5 and select all the 5s. And we're going to go less than that as well, so any number that's lower than that will be part of our answer. We'll hold down the control key and click all of those cells. We see that we have a count of 10, again out of 36. To get the decimal, we'll say equals 10/36. And to write the fraction, we'll say apostrophe 10/36. For part C, we're looking at the probability of rolling exactly 7. So we'll click on all 7 results, holding down the Control key. And we can see that in the lower right, we have a count of 6. That will be 6 out of 36. Now, we'll say equals 6/36 to get the decimal form, and then apostrophe 6/36 to get the fraction form. So this is how we get theoretical probability. If we compare this to empirical probability, you'll see the results were completely different. For example, the probability of rolling exactly 7 under theoretical probability would be 0.16 repeating. However, in our experiment, we got a completely different answer of 0.05. So the empirical probability of our experiment is different from our theoretical probability that we would calculate based upon the sample space. So keep in mind that empirical probability is based on the results that you actually get when you do the experiment, but theoretical probability is based on what you would calculate ahead of time using the sample space. Thank you for watching, and we'll see you again soon.